Sapphire. When you listen to the word sapphire, probably the first thing that comes to your mind is a precious, dark blue, expensive crystal used in jewelry. And you are correct. There are many colors of sapphires. The most common known are blue, but actually, most of the time, they are transparent. Physical and chemical properties. Physical properties. As mentioned before, sapphires are transparent because they are almost entirely composed of a colorless compound known as aluminum oxide. Sapphires have a very high melting and boiling point, 2040 degrees Celsius for melting and 2980 degrees Celsius for boiling. Sapphires have also a low flexibility, high electrical resistance and thermal conductivity. They are hard, actually the second hardest on the hardness scale, just behind diamond. And they also have optical characteristics. Chemical properties. As mentioned before, the most common known sapphires are blue. The blue color only occurs when some of the aluminum cations are replaced by iron 2 and titanium 4 ions. Chemical reactivity. Sapphires are extremely hard. This happens because their ionic bonds are stable and do not need to create bonds with other molecules. That means that their chemical reactivity is really low, making sapphires unable to react with other elements. How the molecule looks like. Molecules of sapphire are complex. As seen on this ball and stick diagram, aluminum is located on the inside and oxygen is located on the outside. Shape and structure effects on properties. Sapphires have an ionic shape and structure, which means that their bonds are stable, making sapphire structure strong and hard. While their bonds are stable, they need a strong amount of energy to disintegrate, making sapphire strong, hard to scratch, have low flexibility, etc. Ionic bond. Sapphires are ionic crystals. This is because they are composed of the elements aluminum, which is a metal, and oxygen, which is a non-metal, creating an ionic bond. Electronegativity. The molecule of oxygen has a higher electronegativity, 3.44, than the molecule of aluminum, 1.5. This makes these two molecules with a difference of 2.39, which means it is ionic, as shown in this example, where the polarity arrow is going to the more electronegative side, oxygen. Polarity effects on the properties of the element and bonding. Because the charges of sapphire are aluminum +3 and oxygen -2, and they are big charges, there is a more attraction between them, making the material harder to break, separate, and create bonds with other elements. Intermolecular forces. There are two types of forces in sapphires. The first one is ion-ion force. The molecule is ion-ion because it is an ionic bond, meaning that there is a cation to an anion attraction, and they have a whole number charge. The second one, London depressure, which is a temporary attraction between the electrons of molecules creating temporary dipoles. But why are we telling you all of this information about sapphires, you ask? Well, ELA Glass is a company who had the idea of replacing weak regular glass with the strong and scratch-free glass made up of sapphire. Aren't you tired of having to take extremely good care of your phone screen every time you go out? Our company has focused on 3 main products in the market. These are optical glasses, phone screens, and airplane windows. By purchasing this glass, we guarantee you, the user, that your phone screen will almost be break and scratch free. You will never have to buy a new pair of glasses because there is a scratch making your visibility less effective, and plain windows will be even thicker and stronger, making and keeping the pressure in the cabin than those that they use now. As you saw in the video, our glass has amazing physical properties, which make it incomparable to other glasses. Say goodbye to broken cell phone screens and no more scratched glasses.